Alright, sorry for the delayed start there. I had to set JUnit up on my Eclipse install. Forgot to do that at any point. Probably be helpful for today's activity. Happy St. Patrick's Day, everybody. If you're here instead of partying for St. Patrick's Day, I appreciate your resolve. Today's lecture is optional, so if you'd like to just work on what you're doing, that's fine by me. But I'm going to go ahead and do some test-driven development to build a simple object-oriented application, and I'm going to try to just kind of contrive to hit on every OOP feature that I can so you can see it at least once, even though that might not be the best idea for what I'm making. So hey, we'll see how it goes. Now in either chat, give me an example of an application you'd like me to make. It can be a stupid game. Whatever you want. I'm going to make it networked too, just for giggles, because most of you have something networked to do and you need kind of a idea of how to do that. I'm not going to finish it by no stretch of the imagination, but I'm going to get as far as I can, and I'm going to make sure that it compiles by the time I'm done here. If not, I'll just make sure it compiles after class and then share it with you. So in either chat, Discord, or YouTube, a drinking simulator, a frog finder. I'm not gonna make any of your applications. GTA 6. I'm gonna make a poll between the options that you give me. So, drinking emulator, frog finder's out because it can't be one of the ones you guys have already. GTA, Rolling Bones. That's low energy. Any other suggestions before I put the poll up? What to do today? What kind of applications should we do? I was gonna do like Mario or something, but alright. If you're gonna be like that. Doctor Simulator. Doctor Simulator. Mario. That's great. I can't do Mario. It's copyrighted content. We're gonna do Barrio. It's Mario, but he lives in the barrio. Orium but drunk. What? Mario? Okay. So many votes for Rolling Bones. I'm gonna make the least charitable interpretation of Rolling Bones. It's humanly possible if I have to do Rolling Bones. It's close between GTA. Uh-oh, GTA is taking the lead. Alright, GTA wins it. So, what is my... This will be the client side first. What's the game actually called? GTA has to stand for something, and it can't stand for the copyrighted work that it's ripping off. So I'll have a GTA client and a GTA server. I'm going to start by pulling the crap that I always use to start everything. This guy work. What does GTA? Grand Test Auto. That's a good one. I do like that one. Let's go with that. It's going to be called Grand Test Auto. Let's use these. These work. Give those to the client. goes to the server, and then I'm just going to take code out of them to make them less useful. Okay, I should have a swing starter in here too somewhere for one of the many classes. That works, sure. Alright. I got a copy driver junk in there. Why I did that? Hey, it opens. Of course, it has a socket error immediately after because it can't connect to anything, but it does open. So that's lovely. Alright, so this is a Grand Test Auto, so I guess I'll rename this to Grand Test Auto Driver. Grand Test Auto Driver. Yeah, you do you, Eclipse. Okay, awesome. Still runs? Yeah, nice. Okay, and then I've got my server that doesn't do anything yet. My client, I'm gonna just, I guess, leave the code in there for now. Okay. And then my display, which just sets up all my click listeners and stuff, but is otherwise blank. Hopefully you've seen something like this before if you've worked with Swing front end at all. If not, this is all going to be very confusing to you, but whatever. Okay, first I'm going to begin by making objects drawable to the screen. So let's call this actor. Anything that's drawable to the screen is an actor, and anything that's drawable to the screen needs to have a public void draw that takes a drawing tool as an argument and allows them to draw. Why do you make things like this interfaces? Well, obviously you want to do it because, come on, you're really going to break my balls like that, Eclipse. Why aren't you importing it for me? Yeah, let me just make the interface the old-fashioned way. So everything that gets drawn to the screen shares a common feature. There we go. What's up with Eclipse? Weird, man. Everything that gets drawn to the screen shares a common feature. It shares a common interface. That means that you should use an interface. It's a good composition choice there. All right, let's do a couple people that might be drawn to the screen. Let's go with a person. And we're going to go with a car. Okay, both of these implement actor. Nope. Stop it, Eclipse. Okay, that leads to some easy assertions. Assert G is not equal to null. Easy. We never want to do a draw with G not equal to null. Now what? Man, my Eclipse is not happy with me today. Oh, I have to save actor. Silly. Alright. So assert G is not equal to null. That's low-hanging fruit, but you have to have it anywhere where there is something where null could cause a significant error. So let's say a person is made of ellipses. Somebody asked, what are packages? What's their point? How are they used? Packages are for organizing your work. If you don't want to make a new project for every single thing you do, you can make a package instead. Some people prefer to make a big project for, let's say, their entire class and do every assignment as a package. Some people prefer to make a new project for every assignment. Now, if you're working on a real project, like, real piece of software, as all of you are, then different modules will be grouped into packages for organizational reasons. Once you got like 50 classes, you don't want to have to look through them all to find one. So you'll group them into different packages for organizational reasons. You can also make variables private to a package by giving them protected status. So you know that private makes things private such that none of the children of that object can access that variable. So private is private to its children as well. And private is, of course, private to all other classes. Whereas protected, so you make a variable protected instead of private, that makes it private only to other outside packages. So yeah, classes in one package can interact with classes in another, but they need to be imported, basically. So I couldn't call, for example, TCP server here. Let me give it a shot and show you what would happen. So if I tried to call TCP server here, it would say no thank you, but it would offer me to import from my other packages, and then once I imported it, I'd be able to use it. However, you can also import from other projects, so it's also offering me to import from TCP server in, oh no, that's the same package there, so no, you can only import from packages in Eclipse. But yes, you can still work with your other classes as if they're in different packages as long as you import them. Generally speaking, though, you're going to try to keep those modules clean without too many imports at the top. It'd be pretty annoying if you had a bunch of imports at the top of every class, because let's say you have 20 classes and you decide you want a package for each of them. Well, that'd be really annoying because there are going to be tons of imports in all of them. That'd be no fun. So, go easy on it. Okay, what else has to happen then? All right, so you've got an ellipse. That's going to be responsible for your display. Let's write constructor for you. So it starts with an x, a y. I'll just have a single variable for person size. Demonstrate the magic of constants. I'm going to write a little bit more code here than I would if it was strictly test-driven, because I want to demonstrate some of these loop concepts too here. So I've made a new ellipse for the person. All people in this world are circles. Graphics 2D is the pencil tool that enables Swing to draw everything. Basically, Graphics 2D is the pen. If you're holding the pen, you can draw to the screen. If you're not holding the pen, you can't do anything. So for a drawing event to occur at the beginning of a frame in Swing, the display method will begin to invoke paint component. It will call super paint component, which erases the screen to nothingness. And then it will instantiate this graphic helper that it takes as an argument. Can also draw in 3D. We don't want to draw in 3D. This is a wonderful 2D game, so we cast it as a 2D. It instantiates our two-dimensional pen, and then this pen needs to be passed along to every single thing that wants to be drawn on the screen, because this pen will draw every single component ultimately. So if this person wants to get themselves drawn, eventually we're going to have to call their draw method, pass them that graphics 2D from the display as an argument, and then they can be rendered to the screen. And we would do that at the end of every, or inside of every single frame where you want that person to be drawn. So you can think of paint component as a single frame draw, and it just draws sequentially from top to bottom using its pen or pencil or however you want to think of it. An ellipse 2D is a circle or oval shape, circular or oblong. Every little graphical front-end utility has something like it, from JavaScript to Java to C# to whatever. It draws a circle at the X and Y location with that size. Now, it doesn't draw the circle, it is the circle. So if you want the circle to be drawn, you would have to actually draw it, and that command is going to be g.fill, and then you would pass the shape that you want to fill in as an argument. There's two variants here. There's fill and there's draw. Fill fills in the inside. Draw draws the outline. So if I want a person to be outlined in black, I need to set color to, why did I just do that twice for? That was clever. I need to set the color to black. And otherwise I want them to be drawn in some other color, so I'm going to give them all a random color at the beginning too. Why not? Let's do that. And the fastest way to get a random color is to use the hex code for the max possible color, FFFFF, that's 6 Fs. And you can take a random number and times it, and you'll end up with a random RGB color. Well, now you're just trolling me, but what is Swing? Swing is Java's very old, garbagey front-end mechanism. Not many things are written in Swing anymore, but Swing still ships with the JDK, so you don't have to import any additional jars or do any extra setup. It just comes with your Eclipse. So Swing is the front end that ships with Java, and it will probably ship with Java indefinitely. It's been shipping with Java for like 20 years, and I don't think they can get rid of it, just because if you want it, they have to ship with something, okay? So they were trying to replace Swing with something else. They were trying to replace it with JavaFX. But JavaFX is awful. Swing is awful too, but JavaFX reached whole new tiers of awful. And JavaFX lacks features that Swing has, and vice versa, which makes it even funnier. So JavaFX ended up getting removed from the JDK, so now you have to import jars and go through all these extra steps if you want to get JavaFX set up, which is a pain in the butt. And since nobody uses either Swing or JavaFX especially much, I went ahead and went with Swing here. But if you look up how to do like any kind of drawing in JavaScript, for example, you'll find that it's almost a copy of Swing too. I mean, you can basically copy and paste until you get to some of the more complicated stuff where Swing falls flat on its face. The simple stuff like drawing ellipses and all that good stuff will be done in Swing. And if you're wondering, no, Swing is not a good platform for game design. It's terrible. Terrible, terrible, terrible. It's not very feature-rich. You can't rotate things, for example, unless you go through a series of very complicated mathematical matrix transformations. So. All right, let's add some more assertions. You want the display to be not equal to null. Okay, we want the display to be somewhere on the screen. How do we get the display to be somewhere on the screen? How do we assert that the display is somewhere on the screen? Well, that's annoying, right? Well, one thing that we can do is get into object-oriented hell and go ahead and create a singleton in our display here. So, public static display instance. Okay, and then we're going to write a method to return it. Instance equals this. Now our singleton isn't quite perfect because it can be null, which shouldn't usually be the case, but this allows us to access the display anywhere we want without having to create a display reference anywhere, which is fancy. Returns the active instance of the display null if one is instantiated. And the convenient thing here is I can do things like assert display dot get, where's this thing? Oop, capital D, static display dot get. Why do you torture me so, Eclipse? Assert that there's a display available that we can actually draw to. That's pretty important. We can also assert that the display dot get instance dot get width is greater than 0. Some stupid things like that to make sure that the display is non-existent. Somebody asked, what's a singleton? That's a hard, complicated question, but essentially a singleton is a class of which only one object exists in the scene or in the program at any given time. So we call it a singleton. And it's a design pattern you tend to see a lot in Java. You tend to see it a lot in Java-based libraries too, like Android. If you tried to instantiate a display, you would be fine here. True singleton, on the other hand, would do something like this. If instance is null, it would create a new display here, instance equals new display, and otherwise it would just return the existing instance, and then there would be no way to actually create a display, so you would render the constructor basically inaccessible. This means that you can only ever have one of these on the scene at once. But static references like this are helpful for when you don't have to deal with complicated dependencies, because you can now access the active display at any time. The problem with this approach is, of course, if you had more than one display, this wouldn't work because your display get instance is static. There's only one copy of it, and there's only one copy of the display instance across the whole program. Every time a new display gets made, it would get overridden, so this would only return the most recent one to you. But if you only have one display on the scene at a time, which is true of many objects, if you have an object where you're guaranteed to only have one, then you can always access them this way by giving them a static reference and accessing them through that. The problem, again, is if you have more than one, this doesn't work because next time you make a display, it'll get overridden. Okay, there's some other crap here. I don't know, I guess we can assert that the shape is within the screen if that's something that's important. So we want to make sure that the display's X position is smaller than the width of the screen. It's another assertion we could make. We could assert the same for the Y. We could also assert that the display is bigger than the other side of the screen. So those might not necessarily be things that we want to do, so maybe I'll leave a note here to do. Is it possible for people to go off the screen? I don't know. Is it? Let's make these private too, so that nobody can mess with them. Let's make these private. So actors can draw, and I think actors should also be able to move, so I'll add that to my interface. I'll give it double X and a double Y. So everything in the scene should be able to move. And I'm going to add my implementation of that. That's going to move the display, because the display is the underlying ellipsy doodad. So display, yes. Okay, it should be pretty straightforward for everybody, but in fact I can just document it on the interface instead of documenting it here. So draws this actor to the screen, and this one translates the actor's display by X along the X-axis and Y along the Y-axis. So again, I could probably make those checks to make sure that you're within the boundaries, or I could make it a part of the way that move is implemented. So if display.x is greater than or equal to, let's say, the width of the screen, then I'm going to set x equal to 1. I'll just loop you over to the other side of the screen. Let's say else, well, I can just make it a series of ifs. If it's less than 0, let's just go greater than. If it's less than 0, then I want to scoot you over to the other side, so that'll be the opposite. I'm just realizing now that that's kind of messy, so let's go with width, so that I have variables for these. Double. Cool, and then I'm going to move it to display width. And replace that. Okay, so if you're greater than the width, you get sent back to 1. If you're less than 0, you get back sent back to the width, and then I'm going to repeat the same thing for y. It's possible to be both at once. Another one of swing's limitations is that you can't really move diagonally with the keyboard keys unless you go through a series of very complicated steps, so it's something we're not going to do very much at all. Okay, then after all of this is done, we should be able to cleanly assert that our display's x is within the parameters and all of this stuff. So we could even write a series for that, test within screen parameters. And this wouldn't be like a JUnit test, this would just be a list of assertions that we would make at the end of any thing like this where our stuff moves. So let's say it's not possible to go off the screen, I'll get rid of that to do, and then at the end of any time that we move the shape, we would test that it's within the screen parameters. So there'd be a series of assertions here for those kinds of things. So just to repeat myself a bit, we'll go with, yes, it's less than the width, it's greater than 0, likewise the y is less than the height, the y is greater than 0, all of that stuff should be true anytime the shape moves. We could also include it anytime the shape draws, whatever. Remember, assertions don't make it into the final version of the program too, but this method will, so that's a little bit ineffective, but that's okay. Runs. And actual test suites will have mechanisms for doing this better than just creating a method for it like I've done here, but I'm going to try to avoid JUnit here because I hate it. Runs assertions to determine if this shape is within the display area of the panel. Okay. Our move method for the car is going to be the same, which leads me to wonder that perhaps I did my composition wrong. Let's look at that in a bit. So first I'm going to add the unimplemented methods here, and then I'm going to do the similar stuff for the car that I did there. So let's do car is going to be a rectangle instead. Simpleton. Why are we remaking the display width and the display height variables? Couldn't you make them once outside of the methods? I could. I definitely might be able to do that for the test method here. On the other hand, what does it really cost me to make them again? Nothing. And what does it cost me to scroll up? A lot. This is always easy to read, and then having to scroll back and forth is a pain. So if I made them, right, if I made them at a field at the top, then I would still have to update them after every move, because it's possible that the display resized between moves. So I'd still have a line like this, I'd just be missing the declaration. So it wouldn't be a tremendous savings. Your goal is to keep the fields of each object as uncluttered as possible, so it's probably better to not have them be fields than to have them be fields. Oh yeah, and if you hover over the documentation for move, note that you get the documentation from the interface if you haven't written overriding documentation. So I already have documentation bound for move and draw. That means you get to write less documentation. You technically have a Java doc for everything if you've documented from your interface. If I did write a document here, then it would override it, but I would still be able to see the root doc from the interface there by clicking through, so also not bad. You would do that when you had some kind of additional features to add. Back to car, which is a sea of red right now. It should be a rectangle instead. It should be a car instead of a person. It still gets a random color. Or what the heck, let's change the constructor a bit so that they're different. This one takes a color as an argument instead of making it a random color. That means that I have to do this because I named them the same thing. Hopefully you understand what this dot color equals color means. Let me know in either chat if you don't understand what this dot color equals color means. Okay, and then drawing is going to be similar. I'm going to actually, again, copy my drawing out of the actor. Looks like I pretty much have all the same stuff here because they're drawn very simply, but I guess in order to show you that there could be a differentiation, let me make a couple of ellipses on the... Oh, you know what, let's make it a rectangle. I have a good idea here. Rectangle 2. Is this my go-to idea whenever I need another shape? It's going to be a hat. People all have hats. Hat equals new. Rectangle 2D dot double. How do you center something in Swing? Well, the X and the Y location are the top left corner. I'm going to have to make a hat size variable to make this effectively. The X and the Y are the top left corner, which means I need half of person size in order to get me halfway to the person, and then half of the hat size in order to get the hat centered on the x-axis, and y is the same, and hat size. Hat size, I'll let you do the math if that was confusing, it definitely was. And then I want to draw his hat too. Everybody gets a black hat. Let's go with that. So g.fill hat. And I don't have to change it. But now look, the draw methods are slightly different. There's a variation between them. It draws the person and their hat, whereas the car doesn't have anything. Alright, so the move method also needs to change for the person. Yeah, because if the display moves, then their hat has to move as well. Okay, so that works. I could add the same series of tests to my car, and I probably want to copy similar code again for my car to do the move. The fact that I'm copying and pasting means that I've done something wrong with composition. So what can I do? What should I have done different? Well, let me tell you, although Actor was a good choice for the draw interface because everything's going to be drawn a little bit differently, everything gets a little bit different objects, Move might better have been implemented as an extension rather than as an interface. So I could have made another class called, let's say, I don't know, movable object, GameObject, something like that. Let's call it GameObject for now. Alright, and rather than having the move method here, I'm going to move it to GameObject. Okay, and what do you want to do if you want to write a method like this and then extend from it? Let's see. Alright, first of all, I'm going to have person and car extends GameObject. It's a bold decision because I can only do one extension, right? You can only extend one thing at a time. So GameObject will be the root. It's possible that they extend something more primitive down the road. Now the base movement of the display is going to be common to all of them. However, the display is inaccessible here, which leads me to probably designing a method like this that takes a shape as an argument. So hopefully this works. Shape get display, and I'll have the default version of it do nothing. In fact, if you have the default version of it do nothing, you can always make it abstract. If it's abstract, then every class has to implement it. Abstraction is like interfacing. GameObject has to be abstract too. Abstraction is a bit like interfacing in that it creates an obligation to create that method. So when you have an abstract method in a class like this, every class that inherits from it has not just the choice, but the obligation to create a getDisplay method. But shape doesn't have an X. Okay, what does it have? Nope, doesn't have an X or Y. So we can't do that. Let's see, what can I do to make the underlying move better? Well, I guess I'll just have to do a position. I'll leave that abstract there just as a demonstration though. Okay, so those would be the base movements. So every game object maintains an X and a Y position. Now it's going to complain that I have unimplemented methods, and I do. And I guess I should document this too. Returns the base display object that tracks the X and Y location of this game object. Person's going to return display. Car is going to do the same. Okay, I managed to move the move method over to here. What does that mean that I can do using the magic of composition? I can do this. I can get rid of all of these things. And I can call superMove XY. And then I can set my display's dimensions to the ones that you get from super. Where did I get this .x from? Whoa. How did I do that? Where does this come from? Let's see. Position of the game object. If you look closely, you see that I've inherited them from the superclass. I've managed to condense move down into just a few lines. I still have this kind of awkward follow-up where I have to update the extra shape, but hey, that's fine. The word composition is kind of broad. Yeah, this is inheritance, but I'm also composing the way I arrange my fields and everything, and I'm doing composition in GameObject to decide where all of those different fields should go too. So a little bit of both here. And then same here, I don't need this move method anymore. I'll inherit the one from the parent object and go for that. So I've done a lot here without actually testing anything. Probably time to test some stuff. One more class, since this is, we'll call this Game Manager. Game Manager. Game Manager will be a true singleton, since everybody wanted to see an example of that. You only have one Game Manager at a time, so. Game Manager is a true singleton. Actually, best to make this private by convention. I think I messed that up here too. Yes. So nobody can change it. Okay, private static instance. Alright, so all it means to be a true singleton. If instance is equal to null, instance equals new game manager, so you create a new one and then you return instance at the end. No matter what. This means that game manager can never be null. Always access it through get instance. You can never make another one. You never make game objects directly. You only access them this way. So you're not supposed to instantiate them directly. What happens when you instantiate it? In the constructor, let's add a couple more things. So we want a let's do array lists. I think people aren't as comfortable with those. They maybe haven't seen those as often. So there's an array list of people in the game. I think I did the syntax wrong there. Yes, I did. Got some extra parentheses. Oh, I did the syntax wrong. There it is. That's a tough one. You know it's hard when the words turn purple. And then I want my cars. Cool. Got my cars. Somebody asked, what's the difference between arrays, hash maps, and array lists? You'll learn all that in 328. But in brief, an array list is just an array that has some fancy features that allow you to not care about its size. And be able to add and remove things without worrying too much about the index. So you can just add and remove things willy-nilly. You don't have to worry about, do I have another spot? I have to shift everything over, all that junk. Hash maps are very useful because they return whether or not the list contains an item in constant time. So if you have an array, even if it's sorted, if it's a billion items long, it'll take a long time to tell you yes or no, is there something in there or not. So if I'm looking for, let's say, a particular car in a list of a billion, that would take a while. A hash map can tell me in constant time. It doesn't matter how many items are in the map. It'll always take roughly the same amount of time. And it can also return the key. A hash map is a value, a key and a value pair. It can return the key or the value to you in constant time. So if I want to know which car is, let's say I want to know if car A is in there, and I want to know what color car A is, and it's a map between cars and their color, I could get that in constant time. Very neat. And arrays should be your data structure of choice, unless you have a compelling reason to do otherwise. So when you start the game, starts the game with some people and cars and stuff. Let's just make a bunch of people and a bunch of cars. Starting people. Starting cars. Yeah, helps to give those a number. Let's go with 20. Go with 10. Do the same with the cars. Oh, that's people. People B. Oh, it's not people, it's person. New person. What did I have to give to person again? Well, I needed an X and a Y position. I could just, I don't know, pick it randomly. Do this again if I wanted to. Somebody made the linked list reversal joke. Linked lists, unfortunately, although we focus a lot on them academically, they're the least popular data structure out there in the real world. At least today, I would say that's true. Of the ones you learn in 328. However, they are extremely popular at job interviews just because they're pretty good at filtering out the people who paid attention in college. So you can expect questions like, how do you reverse a linked list? How do you remove the n from last item in a linked list? So let's say the third from last item in a singly linked list. How do you detect palindromes in a singly linked list? How do you reverse, I don't know, all kinds of linked list questions. Yeah, so get ready for those if you're going to do the kinds of interviews at the kinds of companies that ask you programming questions, which is most of the, I guess, good ones. So isn't it nice to be able to get the width of things whenever you want? Similar thing for cars. Let's say that all cars are black to start. I don't know why I gave them a color if I was just going to make them all black, but okay. You know what, that was lame. Let me just make them white at least then. How do you do those things, people asked. Yes, grind LeetCode. That's the best way to do it. Make yourself a LeetCode account and just start answering questions until you're comfortable doing those kinds of questions. I think you can even categorize them by linked lists if that's an area that you feel you struggle in. No one's going to expect you to answer those kinds of questions for like a junior level internship, so for those you should probably expect things more like about arrays and variable management. I wouldn't say you need to memorize the solutions in general, because there's thousands of those questions out there. You might get lucky and get one that you've already done, but by the time you've memorized 1,000 solutions, you'll know quite a bit about what you're doing. So, yeah, my advice is if you want to get a really good job, if you want to work for a FANG, or if you want to work for a big software firm, then you ought to start grinding the leet code questions out now while you're in college instead of after, when you have no time in your hands. Okie dokie. So that starts off all the cars and the people and the whatnots. And lovely. Okay, so if I wanted to print all the people to the screen, I could do something like this. I made them public because I was lazy. They really should be private and they should have a getter, but I'm doing enough here already. So I'm going to draw this actor to the screen, and I'll do the same for the cars. For cars C. Cool. Alright, well, let's launch it. I guess I'll disable the client for now. Woo! Look at all those cars and people with not hats. Those hats are not well positioned. I gotta fix those hats. That's gonna bother me. Alright. What did I do wrong on the hats? Here we go. It's plus person size over 2. That's right. And then minus hat size over 2. That should be an improvement. Alright. Now they kind of look like Hitler mustaches or something. They're just right in the middle. That's still not what I'm going for. I'm going to be on top. Oh, right. Y plus hat size. Get the X and the Y up there. Good, good. Okay. No, minus. Minus. Up is minus in swing. Down is plus. The top is 0, 0. The bottom is the max. That's not true of every graphical thing. That's more true of swing and its idiocy. Awesome. Look at all those people and their fancy hats. People need to be smaller than cars. It's kind of like that. Okay, people need to not be the size of their hats, though. That's not right. Okay. This is almost acceptable, but they're still not perfectly centered. And I know that's going to bother me, so x plus person size over 2 brings us to the center. And then we want it to minus the hat size. Yes. No. Is that better or worse? That's worse. Let's see if this is better or worse. Worse. You know, I think it's just swing having rounding errors. Darn. Does person just have to be evenly sized? No. Let's go with 25 point some decimals. That works too. Nice. Okay. I'm gonna grab, hopefully I have it here. I had a thing I use. We need to, yeah, there we go. We need to get anti-aliasing in this game. We need to use my graphics card. This class is for gamers only, so there we go. Now it's in HD. Yeah. Nice. Okay, people in their hats and beautiful cars. I wanted to do more with the car colors. Game manager, okay. So let me do something else cool with the car colors. Let's pick a random value from color array, I guess. Color possible card colors equals color.white, color.blue, color.cyan, color.red. Let's make some new custom colors. Random. Who knows what colors they are? Pick a color, any color. So in order to pick a random one, it'd be math.random times possible card colors dot length, and we're going to use that as our index, which means it needs to be cast to int, which means I need parentheses there, and then this whole thing will go inside of the squarey brackets. And at this point I've gotten a very long line, so I'll start a new one. That'll all be a part of possible conc. Alright, cool. Now we get randomly colored cars among the built-in choices. Ah, shoot, we don't. Did I mess up the car's drawing mechanism? Color, color, color. Can do an assertion here to verify that the color is within bounds and everything, too. I have been very light on the test-driven stuff because I've seen a lot of OOP questions, and I feel like those are probably more important to address than the testing ones, but let me know if you want to see more testing instead. Minus 0.5 hat size. You know, I think with the anti-aliasing on, it actually is centered. I think that was just a bug with the graphics not being sufficiently advanced on the regular renderer. So why doesn't car draw in its set color? Oh, miscast here. Put the parentheses in the wrong place. That casts math.random as an integer. Math.random casted as an integer evaluates to 0. Somewhere around here there are some extra parentheses, but don't want to hunt them down, so roll with that. Okay, cool. Random car colors. That's the kind of detail that I'm looking for. Okay, now let's go for the player. Player gets their own object. Is player a game object? Yes, they are. They can move and stuff. Are they also an actor? Yes, they are. They can be rendered to the screen. So the player is a game object. They're also an actor. You could also make them a singleton if you wanted to. I'm not, because I'm going to make it so that only the game manager can instantiate players. The player is going to be a rectangle too. Display. Return it. So this is helpful, right? Every actor, every renderable object can return their display. If you're not renderable, then it would be null. So this is kind of an indication that you're not a renderable object, if that would be returning null at any point. So to draw, the player's color is always going to be something cool like cyan. Cyan's the coolest color. Everybody knows that cyan is the coolest color. Okay. There's player in the constructor. We can take some stuff like we did before. So an X, Y, that probably makes sense. We're going to instantiate the display. Just a new rectangle 2D double. And we're going to put it at X, Y. Let's make a player size. make the player slightly bigger than people. So let's actually just link it to people. So it's going to be whatever persons is. So person dot person size plus 10. So it'll just be bigger than the person size. By daisy chaining them like this, I can force the player to always be larger, and then I only have to change it in one place. Player size. Player size. Okay. That works. Now in the constructors for these guys, I did forget to do something for all of them. I forgot to pass the x and the y along to the GameObject. So I should actually have a super constructor for that purpose. Double x, double y. Is that x equals x? Is that y equals y? Everyone familiar with this dot? Everybody good with that? I didn't get any questions there, but it's one of the more confusing things in 129 at least. So, implicit constructor must be invoked. Lovely. Thanks for not recommending it for me though, Eclipse. Come on, it's an easy fix. Super. Super duper duper. And by convention, it's always the first line. I think it might even have to be the first line. A super constructor. Gotta make sure the x and the y are going to be in the right position. Okay. That's the player, that's their ability to get drawn. We need a movement method. Alright. And let's do a receive. Let's make an enum. I don't think we've had enough practice with enums. I saw practically nobody use them when they were designing anything. So I'll call this move direction. Actually, by convention, it should be like that. Public enum move direction, left, right, up, down. Okay, and then public move direction equals call left by default. You're killing me, guys. An enum is a variable that only has a set number of options. So you've got your ints, you've got your strings, you've got your characters. What if you want a variable that only has a specific defined number of options? Then you can use an enum. An enum is actually also a class in its own right, so you can actually also give each option further properties. So like if I wanted left to also have the value 12 or something, I can actually create constructors for enums and then pass values for each of the properties. You can even give them all methods if you're real extreme. Those are kind of beyond the normal application, but the simplest use of an enum is you got a discrete number of options. In this case I've got 4. You can move left, right, up, or down. I make a variable that only has those 4 options. So now my direction variable, this guy here, the one that's of the enum type, can now only be those 4 values and also null. So it can only be left, right, up, or down. That allows me to do magic like this. Get move command, and this is going to be, it's going to take a move direction as an argument. You know, it's possible that I don't even need a variable of it. I can just do it all through the method. And I can do something like this. I can switch on the direction. And then rather than having to retype all of those case statements like a chump, I'll just have Eclipse auto-generate them for me. And now I don't have to type 4 if statements. And now my life is so much better, because I don't have to type 4 if statements. Public static final double player move speed is 10. So if you're moving down, then you're moving positive on the y-axis. If you're moving left, you're moving negative on the x. Oh, I said 10. I meant player move speed. Right is positive, and up is negative, but that way. What did I just do? Oh boy. Yes. Okay. Moves the player left, right, up, or down by. And then if you want to link, I did see a lot of people do this, you want to link things whenever you reference them. You don't want to just type the variable's name. Gosh darn it, stop being... Alright, so I want to link to player move speed. And now when I hover over the method doc, I can see player move speed there, I can click it, and I can see it's 10. So that's convenient. I'm going to rename this, because that's a crappy name. Call it move player. Okay. So in my display, when you get an arrow key pressed. Okay, so let's do a switch on k.get key code. Let's use WASD actually, because we're pro gamers here. So case key event dot vk. Everything's called vk for some reason. I don't know what vk actually stands for. But the reason you want to do that instead of just reading for W is if the user has caps lock on, it doesn't capture capital W. VKW reads all W's no matter what stupid configuration the user's keyboard has. Even if they decided to try Dvork, it'll still read W. Of course, then it will be in completely the wrong place, but that's their problem for trying the Dvork keyboard. So we want to move the player in this case. All right, Game Manager is going to maintain a player, player, play. When the game manager starts, it instantiates the player. Let's just put them at a default starting location of 50-50. I'm going to keep it public so that I can make it easier to access. Again, out of laziness, there should be a better interface for that than what I'm doing, but we're short for time here. I want to get some crap to move. Okay, so it's going to be get instancing the game manager. All this to avoid making fields, huh? Manager dot player dot move. Sorry, not move. Player dot move player, and then player dot move direction dot W is up. Okay, do the same for all the other keys. So that's A, S, D. Let's do S, A, D. S brings you down. Note that the convention for enums is that they start with an uppercase, so move direction starts with an uppercase, unlike other variable names, but the actual options that are inside are conventionally all uppercase, like finals would be. Default does nothing, but I like to include it. Everybody familiar with switch statements too? Maybe just no one was, but they were afraid to ask. I'm going to go over switches too. Although you probably figured it out by now, they're just complicated ifs. Oops, forgot to actually draw the player. Oops. Manager dot player dot. Boy, I keep doing people. Draw. Oh, it was right there too. The heck am I? I'm not moving around like this. This is wrong. I'm going all kinds of weird directions. Kind of stuck up here too. That's weird. What am I doing up there? Alright. Let's put me in a more manageable place and see what's happening. Where am I at? Whoa, look at me just phasing over there. Oh, I know what I forgot to do. Super.move XY is not updating correctly, so we're going to go to... There we go. Yep. This is what happens when you have 3 variables named x and y. So don't do that. It's a bad idea. There I am. Look at me go. Da-da-da-da-da-da. Da-da-da-da-da-da. I'm robbing all these people, stealing their cars. Maybe. Okay. Let's do something with the game to animate it. Let's call this a game tick. Void move all cars. Okay, car is also going to have an enum. Let's call it enum. I'll do the same thing. I'll call it move direction. In fact, I'm just going to go ahead and copy mine from player. Move direction. And then when you build a car, it's going to have a direction. How do you pick a random value from an enum? I gotta look the syntax up. Pick random value from enum. This one I never remember. It's direction equals move direction dot values times math dot random times move direction dot values dot length. Yes. Okay. Terrible syntax. Okay, so every car gets a random direction when it's instantiated, and then we're going to move all the cars in the scene. So for RC in cars, C dot, I guess I can do the same kind of switch here. So C dot direction. And then we're going to do the same kind of stuff we did. So C dot move. And I'm just going to go with ones for now. So down, left, right. Anything else anybody want to see in the last couple minutes here? What do you mean by object states? What's that question? When did I even say that? I say a lot of stuff. I don't remember. When did I say? What's object states? Don't remember saying anything about object states. Why is my scroll wheel so fast? Gotta dodge those cars. Dodge those cars. Why did they just move off the screen? That's not supposed to happen. Dodge those cars. Alright. Yeah, this is why I wrote all that stuff. What happened there? It's supposed to get reset. Instead, they just went, whee, goodbye forever, my people need me. When we talked about the unit testing. Oh, object state. So, object-oriented programming is all about encapsulating object state into fields. Objects are just little parts of the program state. So, every game object state is basically defined by its fields and occasionally by what's happening to its functions. So, we think of objects kind of as nouns, and we think of their fields kind of as adjectives, maybe occasionally some kind of verbs, and basically trying to determine. Ah, you caught me. We're basically trying to determine if the object's state is valid. So in this case, I have a couple checks that the object state is valid. For person, for example, I ran a series of assertions. It looks like I forgot to turn asserts on for this program, because if I had asserts on, these would have failed. It would have let me know that I was doing it wrong. All right. It's like Frogger. Oh, I'm dead. Go ahead and make it like Frogger. Check death. Car C in cars if P player dot display dot intersects C dot display. I made it private. To avoid having to cast, I'll make an option that returns both. Fortunately, can't do both here because I've got the thing here. Alright, so to answer your question about state, let's go to the player, for example, and let's give them a variable called isDead. Right, so isDead is false by default. When you get hit by a car, your state is going to update to die. Now, to update a adjective, like isDead, you usually have to transfer through a verb in order to update your state. So proper state transitions usually have something like void die, which would set your adjective, your isDeadness, to true. Right, so in this case, the object state is it dead or not? And then there's a method to update its state, die, which sets it to true. And then we need to check if the state is valid. We could do that in different ways. We could check that at any given point that it's moving, it's not dead. So for example, I want to disable the player's movement. A simple state check here would be like if isDead, return. You can't move if you're dead. You're just gone forever. Perhaps I could change your color too. Perhaps you have a color that's cyan by default. Okay, perhaps it turns red when you die. So there's a different addition to your state there. So when we talk about state, we're talking about basically the status of all of that object's properties. That's what we're talking about. We're talking about an object state. What are all of its values? What's null? What's red? What's cyan? What's blue? You should be able to capture the state of the program at any point. So, as soon as I run it here, there's a state to take into account. And, as we go, it updates. So the exposition of all of these cars, for example, that's constantly changing. So you think their state is constantly changing. All cars, check death, and go. Alright, so if I get hit by a car, it's supposed to flag me as dead. So what's the issue here? The player state isn't updating correctly. It's printing you're dead, but it's not properly killing me. So something's going wrong in the way that the player state is updated. Well, I haven't actually called die here, so that makes sense. It should be player.die. Get rid of the you're dead printout. That's just for debugging. Alright, so when you get hit by a car, you die. Let's see. Ow! Well, I'm dead now. I can't move. That's disappointing. Now let's set the car movement speed to make this game more fair. Luckily I use doubles here, so I can transition cars by mini less than pixel units. Too easy. Dun, 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 dun. Oh. See, I wasn't paying attention. That's why you look both ways when you cross the street. Now we notice that there's another glitch with the object state. They kind of float off the side and then they kind of phase. Look at that. This side's fine, right? But what happens when they go up the top? They just phase. That's not cool, right? What are they running into? They're running into the bar here. They're running into the frame bar. Here, it'll be easier to see if I set the background black. Class is over, so you can get out. Hey, that's not fair. I died right away. You can get out if you want. Now you can't see anybody's hat. So hopefully I answered your question about state a bit, and hopefully you know a little bit more about object-oriented programming than you did previously. I tried to hit all the bases. I think I hit abstract classes, interfaces, I hit drawing, which was the big one for a lot of people. I hit singletons. What did I miss? Yeah, I'll update this project to Canvas if anybody's interested. That's fine by me. I'll put it up right after this. I could have documented this more. This is not nearly the level of documentation I would normally expect. You know, even something like this. Checks if the player has been hit by a car and processes their death accordingly. That's just a little joke. That's not even a good method comment. Okay. But yeah, I'll definitely upload this. If there's any other topics you're confused about, I can try to make a more focused, less me just randomly doing stuff example. And if anybody has any particular questions, I've got office hours after this, so I'll be around in Discord if you want to ask anything about this project. But alright, class is way over, so let's call it. See you guys next time. Don't forget to finish your testing and everything. Sorry I couldn't show you more tests here, but the OOP stuff took priority today. So hopefully you get at least a rough idea. Okay, see you next time.